Hey, I'm going to graph some functions here. Let's go. There's some instructions here. Just throw down the graph first. Number one here, looking at a parabola. That's f of x is equal to 1/2 x squared. So if I plug 0 in, I get 0. If I plug 1 in, I get a half. And if I plug -1 in, the same thing happens. Since all my x values are getting squared, same thing's going to happen on either side. That axis. If I plug 2 in, 2 squared is 4, half of that is 2, so like that. And then, well, there's 5 points. I think that's the idea. So plug 3 in, that's 4.5, so I'll just do one more. So looks like this. Got my points on there. Let's see, what else are we supposed to do? Identify, label 5 points. Here's the minimum here at 0, 0. All right. Can we do the inverse? Can this function be inverted? Not the whole thing, because if we inverted it, that's like reflecting it over this line, and it would be a sideways parabola, and that wouldn't pass the vertical line test. So let's see. If we want to do the inverse, we would have to restrict, say that f of x is equal to 1/2 x squared, and say only for x values greater than or equal to 0, and then the inverse of it. You know how to find the inverse, right? You do y equals, if we do it in y equals form, and we swap those, x equals 1/2 y squared, and then solve for y. So that's 2x over here, it'd be a y squared. I have to square root this. I don't have to put a plus or minus in front of this because I restricted the domain to only positive numbers. So we're going to be good there. And then the inverse just looks like every single point that I got here, switch the x and the y coordinate. So 2, 2, that goes to the same place. And this was 3, 4.5, so that's up 3 over 4.5 now. So it looks like that. And we don't get the other part because we restricted the domain. All right. Is it the original function is even, odd, or neither of those? So this is an even function. What does that mean, and how do you know? An even function has y-axis symmetry. That means if I folded this graph over the y-axis, it perfectly matches up on itself. There is a more sort of algebraic way of stating that. A function is even if f of x is equal to f of -x. Which just says if you plug in an x value and you plug in the opposite of that x value, you get the same thing. And we noted that when we were plotting it there. So this is an even function. And any asymptotes? Nope. All right. Next. Maybe just quick comment here about asymptotes. You might think, wait, is this an asymptote because it never goes below that? It's not. It's true that it never goes below this line, but it also doesn't get closer and closer to that line. So an asymptote is something that the function is going to get closer and closer to as x either approaches a number if it's a vertical asymptote or approaches infinity if it's a horizontal asymptote. All right, number 2. Got a line, 3x minus 2. So minus 2, that's the intercept. It's got a slope of 3. I know how to graph straight lines because I went to kindergarten. Just kidding. Probably don't learn that until like 2nd grade. Great. There it is. Got some points on there, so that should satisfy B. Intercept is right there. No maximum or minimum values. If the function has an inverse without restricting its domain, this one does. So x equals 3y minus 2. So then I do the plus 2 over here, divide by 3. So there's my inverse. Let's call that f inverse. right? I want to graph it? Sure. So just there's two ways. You could just graph that new line, or you can just look at all these points and flip the coordinates. So this is like 2, 4, so that would go to 4, 2. Is that 4? Yeah, that's 4. And so on. Notice that this line with a slope of 3, when you invert it, it has a slope of 1/3, because rise over run, which is like y over x, gets flipped over when you swap the x's and the y's, so it becomes like the new rise over run is the old run over rise, if you know what I mean. And any asymptotes? Nope. Is this line even, odd, or neither? Well, it's not even because it doesn't have that fold over. Is it odd? What does it mean for a function to be odd? A function to be odd means like whatever happens on this side of the axis, the exact opposite thing happens. So a great example of an odd function is like the sine function, because it goes up here and then it is like an upside down mirror image of itself here. One way of understanding oddness is if you nail down your origin and flip your graph over 180 degrees, it looks exactly the same as what you started with. So that's why we call it symmetry about the origin. Sometimes you will see it referred to as that. The algebraic definition of being odd is a function is odd if f of negative x is equal to negative f of x. There's different ways you can move the negative signs around, but that's just saying like if you plug in some value, some x value, and then you change the sign, that's what you get when you plug in the opposite thing. So you just get whatever happens over here. If you go to the negative x value, the exact opposite thing happens. That's what oddness is. So this one is number 2 is neither odd nor even. I mean, most functions, if you just like reach into the infinite bag of functions and pull one out, there's an overwhelming chance that it's going to be neither odd nor even. Those are pretty special characteristics. Of course, we like to study special functions, so there you go. All right, number 3, 1/4 x cubed. So 0, 0. Happening. Let's see, if I plug in 1, I guess I get a fourth, and if I plug in -1, I get negative a fourth. So I'm just going to note right now that this is an odd function. This one was even here. This one's odd. Every time I plug in a positive number, if I plug in the negative of that, I get exactly the opposite. So what if I plug in 2 cubed is 8 divided by 4 is 2. And if I plug in 3, that's 27 divided by 4. It's like 6 and 1, 2, 3, 4, 5, 6 and change. I just barely get that on there. All right. There's a bunch of points. Not bad, not bad. Okay, let's see what else we got. Inverse. So could you flip this over? This one is invertible. You can find that inverse if I did x equals 1/4 y cubed. That's a 4x over here, and then I'd have to cube root that. That would be my inverse here. And just have to invert all those points. That's going to be in the same place. So something like that. I did it okay there. Here's the inverse. Swap in all the y's and x's. State whether the original function is even, odd, or neither. We did that. And any... oh, I forgot to say about maximums, minimums. This doesn't have any. So I guess that's why I forgot to do it. And any asymptotes? Nope. All right, so I think we're done with that one. Number 4, 1 over x plus 1. So if I plug in 0 into that, I get 1. If I plug in 1, I get a half. If I plug in 2, I get a third, and so on. If I plug in -1, I blow up the world. Oops. The -1 is a vertical asymptote. So maybe now you're like, oh yeah, this is just like the inverse function. Did you know that the function y, or f of x equals 1 over x, or y equals 1 over x, that is called not it's called the inverse function, because inverse has a couple of different meanings in math, unfortunately. One of the meanings is that if you have a number like 2, the inverse of 2 is 1/2. That's the multiplicative inverse, which means if you multiply these two things together, you get the multiplicative identity, which is 1. So the inverse of a number is just the upside down of it, that sense of inverting. Of course, when you invert a function, it's upside down isn't really quite the right idea. So this is the inverse function, 1 over x, just shifted over, right? Shifted over 1 to the left because of that plus 1. All right, what do we have? We got some points on there. I think we're all set with A and B. Do we have any intercepts? Sure. I mean, we got an intercept here, sure. It doesn't cross the x-axis anywhere. There are no zeros of it. Oh, I guess we should have noted that back here on this one. Look where that crosses here. That's at 2/3, I believe. Identify. Do we have an inverse? We do. If I do x equals 1 over y plus 1, and then I do a little algebra here, y plus 1 equals 1 over x, y equals, actually I'll say f inverse x equals 1 over x minus 1. So there's the inverse. If we want to graph the inverse, this vertical asymptote, when we invert it, will become a horizontal asymptote at y equals -1. And all my points, that point that was here will become here, and so on and so on. So let's see if I can do this. It looks awfully like itself, so it's a little tricky for me. Let's see. Yeah, I'm pretty much confusing myself here. So it's going to go like that. And then down here, it's going to go, that point moves to here. It's going to go like this. So that is a tricky little mirror image of itself. Again, one of the ways of understanding what an inverse looks like is you draw that dotted line, y equals x, and flip everything over that line, because that's what it means to invert a function. You're flipping the x's and the y's. That's got some zeros. Actually, the original function doesn't have any zeros, but the inverse does. And did we do everything? Got our asymptotes in there. Oh, is it even or odd or neither? Nope. This is a big old neither. All right. Number 5. Oh, we get to skip part C, not do the inverse. Okay. So 2x squared plus 2 over x squared minus 1. Don't know what that looks like right off the top of the old head. 2x squared plus 2 over x squared minus 1. Alright, so what's the point of this one? Well, one of the things is, well, let me just make some points first, and then I'll talk about some of the things. So let's try plugging some stuff in here, x, y. I think it's always not a bad idea to just start with the points around 0. Let's crank those out real quick. Excuse me. So I got on the top, when I plug in -3, that's 2 times 9 is 18. That'd be 20 on the top over on the bottom, 9 minus 1. 20 over 8, what is that? 2.5? And then I plug in -2, that's 2 times 4 is 8, plus 2 is 10, and the bottom I have 3, so 10/3, that's like 3 1/3. When I plug in -1, I get, let's see, 2 plus 2, but on the bottom, I'm going to get a 0, so that's undefined there. It looks like that's going to be a vertical asymptote. And here, 0, when I plug 0 in, these things go away. I just get plus 2 over minus 1, so that's -2. When I plug 1 in, I get when I plug 1 in, sorry, I was thinking about something else there for a second. It's undefined again. I was thinking about what I said here. I think I said this is going to be a vertical asymptote, and I think that is incorrect. I'll come back to that in a sec. I take that back. 8 plus 2. Oh, hey, all the things that I plug in, because this is x squared and x squared, every time I plug in a negative or a positive number, I'm going to get the same thing. So I don't have to go through this again. That's going to be 3 1/3 again, and 2.5. All right, so let's see. Try to plot those, see if we can make sense of this. -3, 2.5. -2, 3 1/3. -1, undefined, so I'm not going to do anything there. 0, -2, 2, 1 is undefined again. 2, 3 1/3, and 3. You hear that announcement? Mr. Patterson, he's our technology guy. Busy guy these days, tell you what. Okay, so let's see what is going on here. I want to point out one thing. As we go out and plug in bigger and bigger numbers into this, the x squared over x squared, like let's say you plugged in 10. Now 10 squared is 100, so this would be 200 plus 2 and 100 minus 1. So that's pretty close to 200 over 100, or 2. And as you plug in bigger and bigger numbers, you get 2 times some really big thing over that same big thing, which is 2, and then plus and minus like a very small thing. So you're going to get closer and closer and closer and closer to 2. That's what's happening here. So here, when I get closer and closer to 1, I'm going to get a vertical asymptote here. When I get closer and closer to -1, that's a little trickier, because the factor of, oh no, that's not true, then I also am going to get a -1, so I take back the thing that I took back, or no, I reinstate the thing that I took back. We are going to get an asymptote here too. So I think that's going to look like this. And then in between here, what's going on there? You could try plugging in numbers on either side, and I'm pretty sure you're going to get a thing that looks like this. Now that one's a little harder to graph by hand, I think, a little more challenging. But we get something that looks like this. All right. What other things do we have to do? It looks like this is a little like a local maximum, like in this neighborhood. That's a peak. It looks like there aren't any minimums. We got our asymptotes in there. Y equals 2 and x equals plus or minus 1. I think that's all of it. We were excused from doing an inverse on this one. All right, what's next? 10 over 1 plus x squared. All right, so let's plug in some numbers here. If I plug in 0, then I just get 10. which is up here. Maybe I'll say 1, 2, 3, 4, 5. Let's scale this by 2's. I'm just gonna mark that as 10 there. This is 2. So I get a point there. And if I plug in 1 or -1, I get 5. So this isn't right off the bat here. This is an even function. Oh, hey, this was even too. If you notice like a pattern here, or if you notice here that the even functions that we've seen, if there's only even exponents, then every time you plug in a negative number and a positive number, the same thing happens because the squares square off those negative signs. So that's going to, since there's only an x squared here, no x's or other things to mess up the evenness, we get an even function. If you plug in 2, 10 divided by, that's 10 divided by 5, so that's going to give me 2 there. And as you get into bigger and bigger numbers, like if I plugged in 1, 2, 3, 4, 5, let's say, I get 10 over 26, which is, I don't know, down there somewhere. 1, 2, 3, 4, 5. And bigger numbers, the bottom, the denominator here, is going to get bigger and bigger, and it's going to hug this axis. It's going to get closer and closer to 0. So we get something that looks like this. It's even. There's a maximum there. We got our points. What else do we need to do? Can we invert it? Not the whole thing, because it would... Excuse me. Not the whole thing, because it would fail the vertical line test when we flipped it. But if I restrict the domain to x is greater than or equal to 0, then I can invert that piece of it. And then that would look like, let's see, this point here. It's a little tricky to invert actually because of the scaling. Well, I'm going to do a sketch of what the inverse would look like. This is kind of wrong because it would look something like that. Right, that little peak would be there, but because I messed with the scaling here and it's not squared up, this is 10, but this is only 5 in this direction. That messes up the inverting. So sorry about that. But it would look something like that. Can we find it? Sure. I would just have to do x equals 10 over 1 plus y squared, and then flip that. It's 10 over x, and then move the 10 over x minus 1 over to there, and then do that. Right. And it'll be all good. All right. So I think we did everything there. And I think I'm going to stop this video here and do the rest of them, 7 through 13, on a new sheet in a new video.